Bismillah. Hello, welcome back. This lecture we shall discuss how an image is sharpened. So, sharpening an image means making the image look clear, sharper, and make the details pop up more. The sharpening is very simple. How do we sharpen an image? We find the edges in the image and add these edges on the top of the original image. Therefore, an image plus its edges makes it more sharp. Right, we know that we can find the edges by many ways. One, either by using the Laplacian mask, or by using the unsharp mask, or we can use the Laplacian of Gaussian, or we can apply either horizontal or vertical Sobel edges, or we can find the edges by Privet operators. So there are other techniques. I have taken 5 techniques to find the image, to find the edges of the image, and I add those edges to the image to make it sharper. Let us see how this is done in MATLAB. So image sharpening, that is edge enhancement. Now let us see the first step. Let us read an image. So I take the image, a living room. Then the first step is I have to generate a mask. Therefore I take a mask equal to F special equal to Laplacian. If you want, you can see the values also. The mask 1 equal to, so this is the mask 1, this is the Laplacian operator I use. Alright, once I use the Laplacian operator, now I apply that one. I apply that on an image. Therefore, I apply this mask 1 on the image, and I use the replicate operator so that the borders are not padded with 0 and I don't get a black border. Therefore, this mask is applied on the image, and now I get the edges in out 1. The next step is I add it. Instead of adding, I have put a subtract because my center coefficient is negative. Therefore, minus of minus will become plus. Therefore, IM is my image and out 1 is my edges, and these two are added to get a sharpened image. Now let us see those figures. So this is the original image I have. This is the original image, and when I deducted the edges, I see the out 1. So this one, using the Laplacian operator, I found the edges. Alright, now the image and its edges, I show it in the sharp 1, and you can see that this is the sharpened image using the Laplacian operator. If I show all these things together, this is my original image, and I deducted the edges by means of this operator, Laplacian operator, and now I add this image and the edges to get a sharpened image. Now if you compare these two, this is the original image and this is the sharpened image. It is clear, evident that, see that the edges are very sharp. So this is one technique to make the image very sharper using the Laplacian operator. Right, let us close all these things. Now let us apply the second technique. The second technique is using the unsharp mask. So here I can make an mask using the unsharp, and now I apply that mask on the image. As usual, I do not pad with 0, therefore I put a replicate. But the unsharp mask gives me only the edges plus images, therefore I do not add it. Therefore let us see this one. So let us step 1, let us make a mask for the unsharp. The unsharp mark return edges added to the original. Therefore, let us take the mask. So F special unsharp mask. Therefore, it has given me the mask 2. And now we apply this one, mask 2, on the image. Therefore, this is I am getting not the edges but the edges added to the image. Now let us see that image and see that this is the sharpened using the unsharp mask. Please remember that the unsharp mask does not return only the edges, it returns the edges added to the original image. That is why we do not add the edges. Now if we compare, this is my original image and this image is sharpened using the unsharp mask. So this is another way to sharp the images. You can see that here the doors and other things, and here you can see that the groove and other things are very sharp. Likewise, you can compare the flowers and the part here, and here you can find the flower part is very sharp. Likewise, this filled in the screen is also very sharp, and the table corner is also very sharp comparing to the original figure. Right. Now let us apply the third technique. The another way is we can use the Laplacian of Gaussian. I create a mask, I apply the mask on the image and I get the edges, and since the coefficient is negative, I add the edges. Here actually we subtract, because the center coefficient is negative, negative and negative will make positive. Therefore, the images plus edges will give me the sharpened image using the Laplacian of Gaussian. Now let us see that one. So we shall see the another method. This step number 3, this one, we shall take the Laplacian of Gaussian. Alright, the first step. And here this already we have seen that. Now mask 3. Let us see the another method, and sharp mask we saw that. Now let us see this one. I apply the mask 3. This is the Laplacian of Gaussian. Now if you see the mask 3, mask 3, the center coefficient is negative, therefore I have to put minus sign in the edges. Alright, now I apply the mask 3, I got it. Now I create the image, mask 3, I apply it on the image and I do not pad 0, therefore I use the replicate operator and out 3. So this has given me the edges. Now I add the edges with the image. The edges are added. In fact, it is subtracted because the center coefficient is negative, right? Now let us show that image. This one, the edges I have shown, and now let us show the image. And now if I see the figure, this is my actual image, and if I show the edges, these are my edges. You can see in the title, these are the edges. Now this image and edges are added. This will give me the sharpened image using the Laplacian of Gaussian method. Image, I find the edges, the image and its edges are added to get a sharpened image. So this we got the sharpened image by the third technique called the Laplacian of Gaussian. Right, one more technique is also there, right? So the next one, we shall create a mask 4. This one is using the Sobel operator, and I apply the mask on this image, therefore I get edges, and since my mask is equal to, since my mask 4 is equal to positive, therefore I have to add. Therefore I do not subtract, I have to add. Therefore I apply the sharp 4 is equal to image and its edges. Now let us see the edges. These are the edges which I got using the Sobel operator. Alright, now let us see the image, and this is my sharpened image using the Sobel operator. So this is the sharpened image, and this one is the original image, and this I sharpened using the Sobel operator. Right, this is technique 4. Now let us see the technique 5. This one is using the Sobel operator. Okay, this one I have made it as only the only using the Sobel operator, and by default the Sobel operator, if I see that it has deducted only the edges, and that edges are added to it because the center coefficient is positive, therefore I added it. Therefore in image and its edges has given me the sharpened image. So in this video lecture we have discussed 4 techniques. I find the edge either by using the Laplacian operator and add it to the image, or we use the unsharp mask. Unsharp mask will give me the edges and added to the figure. Then the third mask is the Laplacian of Gaussian, and we add the edges to the image to get the sharp image. And finally the Sobel operator, I find the edges and the edges are added to the image to get the sharpened image. And these are the various comparisons. So the original image, I find the edges and added to get the sharpened image using Laplacian, or sharpened image using the unsharp mask, sharpened image using the log Laplacian of Gaussian, sharpened image using the Sobel operator. From all these 4 sharpened image, it is very clear that the sharpened image using the unsharp mask is better than other techniques. So from the above, it is observed that sharpening using the unsharp mask gives better results. So okay, the remaining thing we shall see in next lecture, and I hope this would have given a simple understanding of how an image is sharpened by finding the edges and adding those edges to the images. We have other operator, preview operator also. Let us try this also. So let us take a mask. This I did not put there, therefore let us take this one. I apply a mask, right? I take the preview operator, all right. Then let us apply that mask on the filter, Control C, and let us apply this one, Control V. Therefore out this I put the preview operator. I did not put a semicolon, therefore it has come like that. Now I get the sharp image is equal to the image plus its edges. Therefore the sharp image is equal to image plus its edges. Now let us show the image. I am show, and this one is equal to the sharp image, and this one is, I give a title. This is sharpened by preview operator. Okay, see that this is the sharpened by the preview operator. Therefore we can sharp either by means of a preview operator, or by means of a Sobel operator, or Laplacian of Gaussian, or unsharp mask, or Laplacian operator. Alright, thank you so much. Please do comment on the video, and please give some positive criticism so that I can improve. Thank you so much.